All right, as you can tell, we have a very old school way of getting this thing started. I've just got my phone propped up on the top of a bunch of boxes or whatever else to film this. Hopefully you're able to see the board very well, hear me. We'll get all this taken care of. The first lesson that we're learning today is coming from section 7.3. It's the logarithms section. Now, just to kind of go back to what we've just got finished learning, we learned section 4.6 and then 7.1 and 7.2. 7.1 and 7.2 were exponential equations where the x's were up in the exponent. And you may be wondering, why in the world would they teach inverse functions with exponentials? Well, the reason is because they want you to understand that the relationship between an exponential function and a logarithmic function is they are inverses of each other. The exponential function is the inverse of a logarithm. A logarithm is the inverse of an exponential. And we'll explain what that means and how that works or anything else in just a moment. But even if you don't understand that, it doesn't even matter in order to understand logarithms, okay? Here's some basic stuff about logarithm, okay? There are three parts in a logarithm. If this is read as log base b of m equals p. And you need to understand there are three things that are in this logarithm. The base goes down here. It's a little subscript, a little small letter. You've got the m as the answer to the problem, which is kind of weird. It's in the middle of the logarithm. And the p is the power. Here's what we mean by that. We're saying that the base was raised to this power to give me this number. And it's in a weird order, but that's how logarithms work. Logarithms have the base as the subscript. The exponent, or the power, is on the other side of the equal sign by itself. It's how exponents come out of being an exponent, is using logarithms. You'll understand that shortly. But let's say you're given this problem right here and you were asked to solve for x. You always can go from logarithmic to exponential form, or exponential form to logarithmic form, by just remembering the positions things go in a logarithm. Here's what I mean. If you have the base, you simply just say the base raised to that power is equal to that. That is taking it from logarithmic function or logarithmic form to exponential form. Okay? It is always base to that power equals the answer. Now you've got a regular equation, no logarithms involved. What's 5 squared? It's 25. You just solve the equation. Okay? Anytime you have a logarithm on one side and a number on the other side, you can always get rid of the logarithms by rewriting it in exponential form. Let's keep going with this. Same thing here. Even if the x is in the base, still can solve it pretty easily. You say base raised to the power. So it'd be x squared equals 49. Now, normally when we're solving equations, we would say, okay, take the square root of both sides, don't forget the plus or minus. So you normally get a plus or minus of it. However, on this problem, I do not put plus or minus, and here's why. Bases inside and the answers themselves can't be negatives, okay? You don't have negatives inside of the logarithm. That's against the rules. So I can't have a negative 7 as the base. So that's why it's just 7 in this context, okay? So that's the problem right there. X is 7. All right, good. Let's go to the next one. Again, they're going to ask you to solve this equation. You're going to simply say base raised to the power. That'd be 3 to the x equals 9. Now, hopefully you can just look at this and say, okay, what power do you raise 3 to make it 9? If you can't, because we're going to see one here in just a moment where you may not be able to see it. Most people can't. If you can't see it, remember, anytime you're trying to solve problems like this, you can always just try to get the same bases so that you could drop the bases. You could rewrite that as 3 squared, that's what 9 is, and since they both have base 3, you just set the exponents equal to each other, and x is 2. Now obviously I didn't have to do that on this problem. You should be able to just look at this equation and say, oh, you had to square it to get 9. But if you can't, you can always solve it that direction. So on a problem like this, you're going to solve for x. You say 4 to the negative 2 power. What does a negative exponent tell you to do? It tells you to flip the fraction. So this becomes 1 over 4 to the positive 2. That's how you get rid of the negative. And 1 over 4 squared is 1 over 16. So that's the equation. Easy enough so far. Let's keep rolling. What if they ask you for a problem like this? They ask you to solve this logarithmic equation. Simple enough. You say 9 to the 1/2 power. What does a 1/2 power tell you to do? Remember, if you have a fraction in the exponent, the bottom number tells you what root to take. If it's 1/2, that's the square root. If it's 1/3, that'd be the cube root, and so on. This is the square root of 9. Square root of 9 is 3. There's your answer. Okay? So on a problem like this, probably as most difficult as it can get, which is not very difficult at all. On a problem like this, you're going to say, okay, go base to the power. You say 8 to the -2/3 power, because you always just say base to the power is equal to what's inside the logarithm. The negative tells you to flip that thing over. The 3 on the bottom tells you to take the cube root. We can go and do that right now. Cube root of 8 is 2. The negative tells me to flip it over, so that'd be 1/2 squared. And to square this fraction would be 1 squared and 2 squared, that'd be 1/4. Okay? Not hard, right? You already know how to do most of this. The only new step to this is getting it from logarithmic to exponential form. We've done all the rest of this. Now, here's one thing that's a little bit different. It's just the way it looks. As a matter of fact, they're not going to tell you to solve this logarithm. They're going to tell you to evaluate. Evaluate just means get an answer, get a value, because there's no x involved. It's just saying, hey, what's log base a to 4? Well, if you don't know what that is in algebra, something we don't know, we can always put an x there and solve like we normally do. That would be 8 to the x power is equal to 4. Give both of these base 2. That's 2 cubed, that's 2 squared. Drop the 2's now because the bases are the same. You get 3x equals 2, so x is 2/3. So log base a to 4 is 2/3. It's that simple. If it's just equal to nothing, you're trying to find out what a logarithm equals, you can always put an x in there and then solve for that. Okay? Same thing here. You don't know what you don't have an x there, and you don't know what log base 5 of 1 is. You just say 5 to the x power, okay, is equal to 1. And then you ask yourself, okay, if I wrote these at base 5, I want them both the same power. 1 to the 5th ain't it. 1 times 1 times 1 times 1 times 1 is still just 1. But remember, if I rewrite it with the same bases, anything to the 0 power is 1. So 5 to the 0 is 1. Now they both have the same bases, so x is 0. The shortcut for this, by the way, and you might want to, hopefully you'll learn this, know it pretty well. Log base any number of 1 is always 0 because it's saying, hey, what power did you raise this base to get you 1? Well, you always raise everything to the 0 power to get it to be a 1, except for 0. But you can't have a 0 there. All right? So that right there is the beginning or the basics of logarithms. Next, we're going to look at logarithmic equations.